All right, let's get y'all. Day 189. I don't remember actually. Let's 180. What is it? Is it you or boat? Oh, it's app. I know. Yeah. Um. Yeah, 89. So good start. We're still in this list. I know, guys. I know some of you guys may not enjoy these types of lead code, but I do need to do it for myself. Just for because I am gonna be a senior this coming semester. I'm gonna be trying to lock in on that new grad stuff. So new lead code is important to me. I don't know. Is it technically programming? I don't. That's probably not. If you however you define it. But I'll count it for myself because, at the end of the day, I'm doing this videos not necessarily for clout. If I really was, I would maybe put more effort in these thumbnails and titles and stuff. It's mainly for me like a video diary of just progression and just now I've made it this far, so it's harder to stop now, and I'm gonna keep going till the end. Regardless, I got a lot a lot more days to go. I do have more. I will do some project stuff. Like I won't be like intentionally doing lead code only, but just for the next few weeks, because I am getting up on closing up my internship pretty soon, so I want to focus on that and hopefully do well on my internship and stuff. But anyway, let's do this. This is the next problem that is not paid. Arithmetic slices. Higher acceptance rate, so I'm hoping it's a little easier than most. So an integer array is called arithmetic if it contains at least three elements, and if the difference between any two of consecutive elements is the same. Okay, makes sense. For example, 1357 and 777 and 3 negative 159 or negative 9 are arithmetic sequences. Okay. Is it at least three elements? Okay. So like for example, here the difference between 1 and 3 and 3 and 5 are the same. Difference between these guys is 2, and it's gonna be the same. The difference between these guys are also 2, so yeah. Number of arithmetic subarrays of nums. So we were finding subarrays. How many? So this one, for this, let's do this one. This is all different. There's 1 here, 2 here. Oh wait, what? 1 here, 2 here. Where's the third one? Oh, the whole array. Oh, okay. 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 Yeah, makes sense. This one can't. So we can like already off the bat. Length of nums less than 3, we can just return 0. That's already a simple case because we need at least 3 elements, right, to start counting those. And then we have 3 arithmetic slices in 1, 2, 3, 2, 3, 4, and the entire array. Now, I want to find a pattern to hopefully get myself to this like window thing, right? Yeah, I think I found it. So we will have like L here and doing as far as you can. and calculate the difference. Then we'll shorten it. Or, yeah, as soon as is size window, then snapshot it, and meaning snapshot as in increment our result, and do it. So we'll fix this, and we'll capture this first, then we'll capture this one, then we'll do this one here, and it will satisfy. We'll capture, and then that'll be end of that, and then this won't be valid, so we stop. So I'm starting to see a solution already. So pretty straightforward here. So we do need to do. I think a while loop might be a little better. Right, and we'll increment, right, because we want to try. Right, and yeah, okay, so we can do a floor or in range of, right, we have this, and we can do L plus 3, I guess. Does that make sense to do? Because we'll be both starting here, but this one will start here, and yeah, here plus 3. We'll be obviously out of bounds, so that won't work. So yeah, then we can start doing our subarray. We'll do that from nums. We will have to copy a little, copy some memory. So yeah. Yeah. I think I won't have to do. So first off, we can just guard ourselves. If L minus, or I guess R minus L plus 1 is already off the bat a pretty bad, like if it's less than 3, we can just return res here. But there's no point in exploring further, so yeah, return res. Right. Other than that, if it's a pretty good size to check, then we will we'll calculate, I guess. I'll make a helper function for this. Def is valid. We'll take an array, or we'll call it sub array, and we'll turn a bool, of course. So for every, we'll do like a prev. Right, for every very val in well, okay, if it's Okay, how do I check this? I guess diff is subarray. Sub. Wait, how do I check if the difference is good? I guess going through it 2 at a time is probably the best move. Yeah, so wait, what is the best way to check? Yeah, checking 2 at a time. I guess diff, we'll have diff here. Subarray. Okay, we'll start with the first 2 values, right? The diff is this subarray 1, right? For every, and we'll have a prev here. 0 or subarray is it here, right? For every val in subarray, we'll do like from 1 to and beyond. Alright, so we have the value. If val minus scrolls, I probably would want to do ABS. If val minus, we'll do ABS, val minus prev equals does not equal diff, turn false, turn true. Makes sense. Yeah, I don't know if this is pretty efficient. Again, I don't know if this is really sliding window, but I guess it's worth a shot. I guess, you know, self dot is valid. I mean, I don't even need this. If right then res 1, yeah. So I think that should be a decent start. We'll see if I run into errors or, you know, whatever. You know, I'm starting to forget object-oriented programming. I did this yesterday and keep freaking up. Okay, we got a wrong answer. Oh, I forgot one thing. Prev equal. Yeah. Damn, okay. Missing something here? Got 1. need this extra safeguard, to be honest. Maybe I'm missing something in the for loop. We're doing like this, right? Nums here for that's 0, so 0 plus 3. Oh, that makes sense. That sucks. 0, 1, 2, 3. Oh wait, no, that's valid. I'd have these 3 elements. Ooh, no. I don't want 3. Maybe 4. Damn, I'm definitely calculating this L point wrong. What could this be? What could this be? Like, then 4 to 4, that's done. So we go next one. I'm starting to realize I don't really need a for loop here. I just need a I don't even need a for loop. Yeah. I just need like sort of a some kind of thing here. I'm missing something. I feel like I can do something here. Well, then I'll miss this. Yeah, that's why it needs for loop. Yeah, that's why I have that for loop in the first place. It's just I don't know where to put L. Yeah, that's why I put L. L plus 3. Right. 0, 1, 2, 3. Yeah, that's exactly why I put it. That's we count 1 here. Let me print all the nums I want. So let's go through that. Run this stuff. Oh, that's exactly the problem. We only go through 1. We should have gone to another one. I think it's because let me run this through, right? So we go here, plus 3. Okay, I see. Maybe a little bit more. I feel like I get an index out of error though. A little better. We'll see how this works. Kind of interested how this would work though. Keely. Yeah, let me see those constraints. Yeah. Unfortunate. Yeah, 5,000 numbers. So we'd have to do like... You know, I'm starting to see a pattern here. Like, we want here. We can increase here, right? Okay, we'll here. Valid. Can we try to increase? Yeah. Or like, try increasing as far as you can, and try decreasing as far as you can. Yeah, I'm getting TLE. It's kind of unfortunate. Here's the thing. Is there some mathematical thing that I can like keep track of here? Because if we have a better way to detect if they have the same difference, right? Like the difference from here, it's like difference between this and this, if that's the same, then 1 and 5 is the same. So maybe some kind of property arises from here, right? Like 1 plus 3 plus 5 is, that's, what was it, 4, so 9. So 9 is odd, maybe some kind of math that comes out of there. Let me see something. I want to see. I feel like it's possible. Like, okay. Like, is there like a property that arises from like 1, 3, 5? Difference is 2, and we get, 9 here, right? Maybe like if it's odd, like, well, like the sum of this is, oh wait, an integer array is called arithmetic if it consists at least 3 elements and if difference between any two consecutive, oh shit, between any two consecutive, so yes, it has to be these two. Like, these aren't, 1 and 5 isn't consecutive, so it doesn't matter. So, I mean, like, 7 plus this 21, that's odd, Okay, now this is interesting. I actually don't know how this would, stand up here. Like, I didn't think of negative cases, to be honest. -1 minus 3. Thing is that we're not really doing any like arithmetic. Like 1, 2, 3, 4. 1, 2, 3, 1, 2, 3 is valid here. 1, 2, 3 is 4 valid, and this is valid. For sure, this generates what all the subarrays I want. Right. But the problem is probably the problem. Wait, let me double check. I should only be creating 3 subs. Yes, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. That's wonderful. We are generating the correct amount of subsets I want to have, right? But I obviously want to check their values, so my checking is a bit bad because I have to go through that sub thing, 1, 2, 3. I wish there was like a quick way to know. Unfortunately, there is not a quick way to know, so. An integer array is called arithmetic if it consists of at least 3 elements and if the difference between any two consecutive elements is the same. An integer array is called arithmetic if it consists of at least 3 elements. What is the sum of this, though? Is there something that I can help me here? DP? What? Okay, let's try to identify the slidingness, right? We have a fixed window. Oh, yeah. Boom. 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 Like, let's say it hits condition, meaning it's size 3. Check for validity. Like, okay. What if I get like a running total? Boom. Boom. Yeah, I'm kind of stumped. I might have to look at the solution here. Sorry. What could it be? Oh, that's DP. Not fair. I want some sliding window. Your job is to go through the array, find all sub-arrays of length 3 or more where the difference is consistent and count them. These must be contiguous, meaning no skipping numbers. Right? So, what's the goal? Find how many of these are little coparentheses existing, right? That's it, and trust they're elegant to this. So, we go through that. I plus 1 minus numbers of I. Begin j plus I plus 2. Keep checking the difference. We count every time this condition holds. Start at index I. Initialize I plus 1 minus sure. Okay. That one's a bit cheeky. Without extra space. Wait, so it goes through the thing, computes the current difference. 2 minus 1 is 1. If the current difference and difference, if else, if cur is greater than 1, res, that's a bit weird. I don't know. I don't see how that's sliding window, to be honest. Okay, this one looks more reasonable. If we ever go through, check if nums are right and equals to diff. Left equals right minus 1. Difference is this new thing. That one's pretty elegant, actually. We can use sliding window for this problem by left equals 0 first, and then initialize diff at the first two elements. Since we know that we can iterate from 2 to n minus 1. If the difference between it and its previous number is equal to the current diff, we can treat the right as the end of the valid subarrays, and left can be shrink. Then there's just right minus L, left minus 1 position. So we have to make sure that right minus L minus 1 is greater than or equal. So fuck, that was kind of a crazy solution. This is a new type of sliding window I am discovering. Yeah, that's kind of an L on me. I've never seen this type of sliding window. So like, obviously, yep. So we have left. We'll do a classic way right here, right? Diff is the current. I'll do res here as well. Right, and diff is gonna be nums 1 minus nums 0. For every r in range from 2 to length nums. Right, so we go through it, check if the difference of where you are and where you will and the previous elements is equal to the difference. If it is, then everything from that point on is valid. Damn, okay. res equals max 0 r minus L plus 1. Right, but this is only if nums of r minus nums of r minus 1 equals diff. Now if this isn't the case, then we L2 r plus 1 and set the diff equal to this, whatever this new one is, right? Wait, why are we doing this again? Right, like this? Wait, why? What? Wait, if it's not the case, then oh yeah, that's what I meant. Yeah, this is the same shit. Yeah. Yeah, okay, that was just cleaner. I see. Basically, take this, make that the new diff, and then repeat again, and then she'll return res. Wow, that is such a clean solution. Oh, of course. Oh, I got this wrong. Interesting. Oh. Why do we write? Why? It's even worse. What has happened? Oh my god, bro. It's plus. So basically we're doing here is we'll do the first two numbers. It will be a difference of 1. We'll go from 0, 1, 2. We'll start from here till the end of the list. And we'll take the current one and the previous one. Check that. That'll be a difference of 1. So, yep. Will be 3. Would be 0, 1, 2. 2 minus 0 is 2. Or 2 minus, yeah, 2 minus 0 is 2 minus 0 minus 1 is 1. So we increment 1. Then we go up to here. Right, it's the same diff. We'll check if 4 is here and minus that is the same diff. So we'll do 4 or 0, 1, 2, 3 minus 0, 3 minus 0, which is 3, minus 2. Damn. Because if we know that this is valid, then we know that every subset of it is valid. Oh my god, that is the side, bro. I don't know how you calculate that math. I don't know how you found this formula here. That's really tricky, but that was nice. But anyways, that should be good enough for today. Decent amount of time. Anyways, thanks for watching. I'll see you around. Peace.